in this lecture, we will study the basic interfacing concepts. In any application of microprocessor-based system requires the data transfer between the external device to the microprocessor and microprocessor to the external device. Now, for that, we need this input port and output port. Now, what is port? Where the I/O devices are connected to the interface, that point or that node is called the port. Now, input port means what? Microprocessor read the data from the input device by using this port is called the input port. Now, output port means what? Microprocessor writes or sends the data to the output devices such as display from the microprocessor. Then for that we are using the output port. Now here it is a output port. This output port we are connecting the output device display. Now if you see here, for the input port, one side input device is connected and another side data bus is connected, and this data bus is going to the microprocessor. And in this microprocessor, the data is placed into the accumulator. Through the accumulator only we are transferring the data. Now similarly, so now again the processor is this data bus is connected to the processor. Now in the accumulator, whatever the data is there, that data is sent to the given to the output port through this bus, and it is stored in this. And whenever the devices are ready, then this data is placed on this data and given to the output devices. So this is called output device. If you see here, here it is a latch. That a latch is enabled by using the clock. Now in the input port, if you see, this port is a tri-state buffer that is enabled by using the enable signal. So now what is tri-state buffer? Already you studied the inverter in the digital electronics. Now if this is A and Y is equal to input is A, Y is equal to A bar. So whatever the data you will give, you will get at the output, you will get the complement of that data. 0 if you give, 1 you will get, 1 you give, 0 you will get. Now this is about the inverter. If you don't have this bubble, then this is called the buffer. Now whatever the data you will give, that is available at the output, Y is equal to A. Now what is tri-state buffer means? Now in this case, if A is equal to 0, then A is equal to 0, Y is equal to 0, A is equal to 1, Y is equal to 1. Here you have a 2 states. Now coming to the tri-state means what? By using the enable signal, you are controlling the output. Now you will get the input at the output when the enable pin is equal to 1. When E is equal to 1, then Y is equal to A. Then E is equal to then you don't get anything at the output. Then the output is called the high impedance mode. Means what? If you take input and output, input is A, output is Y. When enable signal here, if enable is equal to 1, A is equal to 0, Y is equal to 0, A is equal to 1, Y is equal to 1. This is one state. Now if enable is equal to 0, whatever may be the input, your output is always high impedance mode. High impedance mode means what? Neither 0 nor 1. Output signal is neither 0 nor 1. So this tri-state buffer is having the 2 inputs, 1 output, and it is having the 3 signals. One is a logic 0, logic 1, and a high impedance signal. Means what? In between. Here in this high impedance mode, no signal, no current flows. Here this tri-state buffer will not store any data, just it will transfer the data. Whatever the data is given by the input device, that is placed on the data bus when the enable signal is applied. Coming to the latch, now latch already you have studied in the digital electronics. That is nothing but it is designed by using the gates, and it holds the binary value. So by giving the clock signal, whatever the data is stored in this latch, that is placed onto the bus and it is given to the output devices. Now here the difference between tri-state buffer and latch means what? Tri-state buffer can't store any data, but latch can store the data. So this is about the input port and output port. Now here, how to give the data to, how to read the data from the input device means what? By using the in and port address. So this is an instruction used to read the data from the input device. And how to send the data to the output device means the instruction is out and port address. Now, what is this port address? Now, already you have seen in the microprocessor, it is having the 16-bit address line, and each memory location address is consisting of 16 bits. But now here, if you see the IO devices, maximum it can connect to 250. So here we are using the 8 bits to represent the address for these ports. So total 256 IO ports can be connected to microprocessor 8085. So only 8-bit address is used to represent the port address. So now here we are giving the in port address means what? 8-bit only. Then 16-bit address bus we are using. That time if you are specifying only 8-bit data here, then the 16-bit address is divided into two, lower order address and higher order address. So this 8-bit data is given in the lower order bus, as well as the same address is placed on the higher order address also. So now here you have seen that to read the data, transfer the data from the memory to the microprocessor, we have used the move instruction and LDA, STA. So the load accumulator, store accumulator, these are the instruction SHLD, LHLD. So these are the instruction we use to transfer the data from the memory to the processor. But here we are using the separate instructions to transfer the data from the IO devices to the memory. So different instructions we have used for the memory and IO devices. That's why 8085 is the what? Isolated IO. Means what? Same memory location is used for the IO devices and the memory. So addresses are same, but what instructions are different. That is isolated IO. Now we will see the instructions, in instruction and out instruction. Now here this is the syntax for the in instruction. In 80 means what? 80 is the port address. Now here we may have the so many input devices and output devices. Now these devices where you are connecting, that pointer is having one address that is called the port address. So, now if you are connecting the mouse and your keyboard to the CPU, where you are connecting, so that each and every connector is having one address that is called the port address. So now here I have used one instruction. In 80 means what? 80 is the port address. Now here also I have to write 80. Now from the port 80, the data is placed onto the accumulator in the microprocessor. So accumulator, that is called the in instruction. In is for reading the data from the input device to the microprocessor. Okay. Now for this is the opcode, and this is the port address, whatever the address we have. This is a 2-byte instruction. The first byte consisting of what? Address, opcode, and the second byte is what? The port address, whatever the address we have given, that address. So now to draw the timing diagram for this, how many machine cycles are required? Default, the first machine cycle is a fetch machine cycle. And after decoding the opcode, processor understands that it has to read the port address from the next consecutive memory location. So for that, what memory read operation takes place. And after reading the port address, and the processor should read the data from this port address, and that data should be loaded into the accumulator. Means what? IO read operation is taking place. So here total three machine cycles are required to represent the timing diagram for the in instruction. Now this is the timing diagram for the in instruction. So first machine instruction is opcode fetch, next one is a memory read, and the last one is a IO read. If you combine all these three machine cycles together, then this is the timing diagram for the in instruction. Now here if you see, the first opcode is placed in where? So first opcode is 6000. So now here 60 is loaded, 00. So first address is given, and after that in that what? ALE is high means what? Lower order is acting like a address bus. Now this time we are accessing the memory. Now instead of writing IO oblique M bar, you can write IO oblique M bar, S0, S1, all three together you can represent. Otherwise, if you don't need, if you want to represent like separately, now in this case, what are we doing? We are accessing the upcode means where the upcode is stored in the memory location. That's why we are accessing the memory. So that's why what? Memory is activated here. So memory signal is given. IO oblique M bar means what? If you give the 0, then memory is accessed. If you give the 1, IO is accessed. So opcode fetching is taking place. That's why what we are accessing the memory. So signal is going low. So reading the opcode. So read signal we are giving here for the second clock pulse. So in the second clock pulse, ALE is low means what? This is a lower address bus acts like a data bus, and opcode is fetched. This is happened in the third machine cycle, 2 to 3 machine cycle. So 2 machine cycles, and in the fourth machine cycle, internal operations will take place. Nothing but what? Decoding is taking place. So and after that what? After upcoding and decoding is done, then microprocessor understands that it has to read the port address in the next location. Means what? 60 is a higher and 01 is a low. Now this in this location port address is there. So that's why it is keeping 06001. For the first clock pulse, it is acting like an address, and after that what, it acts like a data bus, and it will read the port address 80. And after reading the port address, how it is reading? By giving the read signal. Now here also by giving the read signal, opcode is fetched. By giving the read signal, a port address is uh, uh, taken by the port address is read by the microprocessor. Now in this also memory is accessed. Now if you don't represent these two also, nothing will happen. This is nothing but what? Memory read. Here you are showing the memory, here you are showing the read. Both combinedly together you are taking the memory read. IO read operation means what? For the fetching and for the memory read operation, IO read operation is not accessed, no, so not considered. That's why it is what? High. Bar is there means what? Whenever you give 0, that at the time only it is enabled. Now it is high means what? It is disabled. So if you don't show these two also, nothing will happen. Why? Because by showing these two is nothing but what? This and this. Okay. Now coming to that, after reading the port address, now port address is kept here, 80 is kept here. So if the lower port address is 80 means what? Port address for higher byte is also 80, because in port address is a 8-bit address. Here we have a 16-bit address bus. So whatever the port address we are giving, the same port address is taken in the higher order also. Now in this port address, whatever the data is there, that data is placed on the accumulator in these two clock cycles. Now for that what? We need to give the right answer. Again here also read operation is also be taking place. So read signal is given. So and here in this case what? IO devices are accessed. That's why IO oblique M bar. In this what? IO signal should be given 1 to access the IO devices. So this is about the in instruction. Similarly, we will see the out instruction. Now out 81 means what? In the 81 from the microprocessor, accumulated data is given to the port address 81. Means what? Write operation is taken. So if the data is sending to the IO devices, processor is sending the data to the IO devices, that is the write operation. Processor is taking the data from the IO devices, then that is the read operation. No, from the accumulated data is going to the port means what? Write operation. Now, in this case, it is a fetching, and after that fetching, so it understands that it has to get the port address, and after reading the port address, now microprocessor has to write the data into this port address. Means how many machine cycles are there? The first one is fetching, to fetch the opcode, and the next one is what? Memory read, to read the port address, and after reading the port address, accumulated data content should be placed in this port address. Means what? IO write operation. So total 3 machine cycles are required to represent the out instruction. So this is the timing diagram for the out. Similarly, how we have analyzed for the in, same analysis we have to do. Only the difference is what? For the third, this is IO write operation is taking place. That's why we have to give the right signal, right signal. So low signal means what? Enabled. High means what? Disabled. So for first 2 machine cycles, write operation is not enabled, and for the third machine write operation is enabled. The remaining analysis is same. However, we have done for the in operation. Okay, if you don't represent this 2 is also okay. This is about the basic interfacing concepts.